지금부터 2026 국제화재감식컨퍼런스를 시작하겠습니다. 참석자 여러분께서는 행사장 안으로 입장하여 자리에 착석해 주시기 바랍니다. 원활한 행사 진행을 위해 가지고 계신 휴대폰은 진동으로 전환해 주시거나 전원을 잠시 꺼주시면 감사하겠습니다. 오늘 2026 국제화재감식컨퍼런스의 사회를 맡은 김효현입니다. 반갑습니다. 국제화재감식컨퍼런스의 관계로 제가 한글로 말씀을 드리고 그 이후에 영어로 또 말씀을 드리도록 하겠습니다. 바쁘신 와중에도 4차 산업기술 시대의 새로운 화재감식 패러다임을 논의하는 이 귀한 자리에 참석해주신 내외 기빈 여러분과 모든 분들께 진심으로 감사의 말씀을 드립니다. I would like to express my sincere gratitude to all our distinguished guests and attendees for joining us at this important event to discuss a new paradigm in fire investigation in the era of fourth industrial revolution technology, despite your busy schedule. 지금부터 대한민국과 세계 소방의 미래를 조망하는 2026 국제화재감식컨퍼런스를 시작하겠습니다. 박수 주시면 감사하겠습니다. Let us now begin the 2026 International Conference of Fire Investigation, where we will explore the future of the fire services in Korea and around the world. 다음은 오늘 자리를 빛내주시기 위해 참석해주신 주요 내빈 여러분들을 소개해드리겠습니다. 한 분 한 분 소개해드릴 때마다 힘찬 박수 부탁드립니다. I would now like to introduce the distinguished guests who have graced us with their present day. Please give a warm round of applause as I introduce each guest. 첫 번째로 제임스 브라이언 패티슨 교수님입니다. 박수로 맞이해 주시면 감사하겠습니다. 다음으로 중국의 흔한 분입니다. 박수로 감사합니다. 다음은 키르기스탄의 카라타이 행정관님이십니다. 다음 한국화재감식학회 박성호 회장님이십니다. 다음 한국화재감식연구소 김효범 소장님이십니다. 다음으로 한국화재폭발조사협회 최찬돈 부회장님이십니다. 다음 한국화재감식학회 김영일 부회장님이십니다. 다음은 이번 컨퍼런스를 주최하신 박성호 회장님의 개회사가 있겠습니다. 큰 박수로 맞이해 주시기 바랍니다. Next we have the opening remark from President Park Sung-ho, the host of this conference. Please give him a warm round of applause.
It's a great pleasure to have the international conference at the beautiful Jeju Island. So by this international conference, we can cooperate worldwide fire investigators, and also we increase the potential power to investigate fire and explosion research. So especially thanks to everybody coming from Mr. James from United States and Hunan from China and Kartai from Kyrgyzstan and yes, so we are so very busy at especially for our fire investigating and the fire exposure research. So that I'd like to mention a couple of things. 이게 그냥 얘기를 하면 집에 가면 잊어버려가지고 이런 얘기를 좀 할 걸, 저런 얘기를 좀 할 걸 그래가지고 제가 좀 몇 가지 코멘트를 적어왔습니다. 이번 국제 세미나는 단순 학술 발표의 장르로만 우리가 현장에서 치열한 경험과 지혜를 서로 나누고 우정을 쌓는 소중한 기회가 될 것입니다. 특히 최근 화재 안전 분야의 핵심 화두인 AI, 로봇, IoT, 기술이 화재 감식 및 대응에 어떻게 혁신적으로 기여할 수 있는지에 대해 심도 있게 논의하며 국제적 협력의 중요성을 다시 한번 확인하는 뜻깊은 시간이 되기를 바랍니다. 이번 세미나가 서로를 격려하고 지원하는 화목한 분위기 속에서 여러분의 전문성과 경험이 존중받으며 함께 성장하는 계기가 되기를 바랍니다. 아울러 이 자리가 우리 학교가 더욱 단합하고 발전하는 중대한 전환점이 되어 참석하신 모든 분에게 의미 있는 기억으로 남기를 희망합니다. 저희 학교는 다가오는 하반기 9월 정도가 될 거예요. 9월달에 대한민국 국회 대강당에서 6개국 전문가와 외국인 귀빈 30여 명이 오늘 초청하여 300여 명이 모인 가운데 다시 한번 국제 세미나를 개최할 예정입니다. 전 세계 화재 감식 기술을 공유하며 국제적으로 육독성 회의 모습을 여러분과 함께 만들어 가고 싶습니다. By this international conference, we can increase the power how to investigate the cause of fire, and also furthermore we can save the national potentiality to save the valuable people. So also we can especially the national wealth, how to reduce the national wealth. So 다시 한번 제주의 아름다운 제주도에 오셔가지고 일상의 아주 힘든 일상에서 벗어나고 좀 릴렉스할 수 있는 기회를 여러분들이 가졌으면 좋겠습니다. 이상으로 마치겠습니다. 감사합니다.
네, 대한민국 소방 발전을 위한 힘찬 메시지 감사드립니다. 다시 한번 큰 박수 부탁드리겠습니다. Thank you for your inspiring message regarding the advancement of the fire services in South Korea. 오늘 컨퍼런스는 AI와 로봇 기술을 중심으로 각국의 선진 소방 시스템과 사례를 공유하는 일부 국제 컨퍼런스, 더 깊이 있는 논의를 위한 2부 패널 토론 순으로 진행됩니다. 끝까지 자리를 빛내주시어 유익한 정보와 지식을 나누는 시간이 되시길 바랍니다. Today's conference will proceed in the following order. Part 1, an international conference focused on AI and robotics technology, where we will share advanced firefighting systems and case study from various countries. And Part 2, a panel discussion for more in-depth derivation, We hope you will stay with us until the end to make this a fruitful opportunity to share valuable information and knowledge. 그럼 지금부터 본격적으로 4차 산업기술 시대와 대형 화재 예방을 주제로 한 국제 화재감식 컨퍼런스를 시작하겠습니다. We will now officially begin the International Fire Investigation Conference on the topic of the fourth industrial revolution and large-scale fire prevention. 첫 번째, 미국 제임스 브라이언 패티슨 교수님을 모시고 미국의 대규모 화재 사례 연구에 대해 들어보도록 하겠습니다. For our first presentation, we welcome Professor James Brian Pattison from the United States to discuss case study of large-scale fires in the United States. 큰 박수로 맞아주시면 감사하겠습니다.
I've seen you for years now, and I'm happy every time I get to see you again, especially you, sir. You guys are the thing that brings a smile to my face because I see the kind of bravery and courage that sets men apart in the fire investigations. The police and the army too, but firefighters in particular are those that I think exhibit the bravery that turn us into men and women of heroic stature. Today I'm going to be talking about 3 different cases. 3 criminal cases, and there's a reason for that because I used to be a criminal lawyer, right? So I used to come up against cases where someone has been accused of arson or murder or other types of cases, and it was my job to find the holes in the prosecution's case. For a couple of years I was a prosecutor, but for the most part I was a defense lawyer. And so I've looked specifically at these 3 cases that we're going to be looking at today. That's the cases of Todd Willingham, Ernest Lee Willis, and E. Han Tak in the United States. All of these cases resulted in a conviction. Somebody was found guilty of arson, and people died in the process, their family members. So they were found guilty of murder. One of them, Willington, was found guilty and executed by the state. The 2 others spent 17 years in prison and then 24 years in prison for Yi Han Tak for killing somebody using fire. The problem was they didn't do it. So an innocent man was executed by the state. And 2 people spent a total combined period of time of 41 years in prison before people took a look at their cases and found that they were really not guilty. So how were they found guilty in the first place? They were found guilty in the first place because we had fire investigators with years of experience, fabulous experience, that would testify in front of the courts that certain things indicated that these were arson cases. That somebody deliberately set these fires in order to kill the people inside the buildings, family members in all cases. That was the testimony of the fire investigators. What evidence did the fire investigators rely upon? They relied upon what we call rules of thumb. Rules of thumb. A rule of thumb is a rule that everybody accepts as true, because long tradition has gotten us all to think that it's true. You walk into a place that has been burnt down and you see a hot spot in this space, you say that's where the fire began. It's a rule of thumb. Well, the rules of thumb in these cases resulted in conviction of these 3 men, 2 of which spent a combined total of 41 years in prison, and 1 of which was executed. None of whom were guilty. So, the cases, Willingham, Willis, and E. Han Tak. It's a little difficult to talk and carry that around at the same time. America, like all countries, including Korea, has traditions. Unique ways that fire investigators look at situation and determine who was responsible for the fire. We looked at certain things like traditional indicators. We call them traditional indicators. In other words, these have been used, the rules of thumb, pour patterns, right? Looks like someone poured gasoline or some other type of fuel or alcohol or something in a specific area. Pour patterns. Low burning, which would suggest that the fire was following at first a liquid accelerant, right? Low burning. Multiple points of origin, which makes it look like a fire was started there and then there and there. Many points of origin. Crazed, that is cracked glass. Glass that, because something got too hot too quickly, it started cracking and had a very strange pattern. It was like looking through a screen door, right? It's crazed or cracked glass. Alligatoring, which is where wood or other materials would get, instead of their smooth surface, a rough surface that looked like it was the skin of an alligator. Clean burn areas and other types of traditional indicators. The problem is, the pour patterns are not caused necessarily by somebody pouring accelerant on the floor or on bodies or on things that happen to be in that particular structure. There's multiple other causes. Sometimes you can get the same pour pattern appearance by something that has had a flashover, right? Re-burning with such intense heat that everything inside the structure takes fire again at the same time. Reality is post-flashover can also explain low burning and multiple points of origin. The reality is that the spread, the airflow, right? The wind coming through one window and out the door, or some other way. Collapse of a roof can also explain the multiple points of origin. Cracked, crazed glass, it's not just rapid heating, but it's a rapid cooling. So as the fire starts to die down, that's when the glass could be cracking, rather than when it was started or as it got hotter. The reality varies by material with regard to alligatoring. Clean burn areas, reality, ventilation, airflow mimic the same clean burn areas that investigators relied upon to say that it was arson in previous cases. Traditional indicator, other various explanations, all of them in the alternative. So the three cases we're looking at, there's Willingham, there's Willis. Down on the third line you see Lee, right? That's the E Hantai. This is in the United States, all three of these cases. In Willis and Willingham, we saw wrongful convictions when these guys were convicted of pour pattern analysis. Fire investigators said pour patterns demonstrate that there's arson in this case. They were convicted also, at least Willingham was wrongfully convicted, when the arson investigator said that there was low burning. Both Lee and Willingham were wrongfully convicted on the investigator's testimony about multiple points of origin. Willingham, in this wrongful conviction, also showed that the cracked glass indicated arson, but it also indicated not arson, which is very interesting. The problem is, before the court came to believe that it indicated not arson, Willingham was dead. He had been executed. And alligatoring, that was in the Willingham case as well. Willingham was a big case. Clean burn areas, and others, of course. Lee and the experts have gone over other types of traditional rules of thumb for arson investigation, and has demonstrated that most of them, if not all of them, are wrong. They're still useful, still very useful, but they're not something we can, what we would say in English, hang our hat on. We can't put our hat on these things and say that's where it belongs. It's just an indicator of where we should look next. So these are helpful hints, but they're not dispositive. They can't determine the cause of a given fire. Indicators were never scientifically validated. By the time the fire investigation associations in America got together and started talking with one another, scientists started getting involved, and the scientists started saying that all of these traditional indicators have a problem. Under laboratory experimentation, they were able to demonstrate that all of those traditional indicators, those rules of thumb, were not quite as sure as people thought they were. Which is why, 24 years later, they looked at the Hantak case and found that the evidence was in his favor, not against him. And they were able to go back. Science was finally involved, which is why I love this conference, because this conference has science written all over it. And science is what is starting to give credibility to traditional indicators. So the traditional indicators, like pour pattern, it was undermined, it was disproven by the NFPA. What is the NFPA? National Fire Protection Association Standards, number 921. It's a document that is written by fire investigators and scientists working together, which has become what they call the gold standard. What is the gold standard? We don't have a gold standard anymore. But there was a time in the world when the United States used to determine the value of its dollar by looking at the value of gold. Gold was the standard for the determination of the value of the dollar, the gold standard. So when we talk about the gold standard, we talk about something that everybody can trust. You can no longer trust the traditional indicators, but you can trust the NFPA 921. So NFPA 921 has become the gold standard to the extent that whenever we have court cases, people can pull out the NFPA 921 and say, we did this scientific investigation, we got people who looked at it with us, peer review we call that, and we subjected it all to testing again. You can rely on what we say in this case. Courts, judges would look at that and say, okay, well that changes things. No longer do we have to just rely on the old like me, right? Fire investigators. We can look at the standards and the science that is involved. So scientific study is part of this. NFPA undermined the multiple points of origin traditional indicator. Scientific study took out the crazed and the alligator. NFPA and science took out the clean burn areas, traditional indicators. NFPA, science, cases, no statutes, there were no laws written. It was all the private industry of people involved in fire investigations. And some fire investigators that work for the public, obviously. They work for the cities and the counties and the states and the government, right, to be involved in these things. But they involve a lot of private science as well. So, scientific validation is what we have learned. When you investigate a fire, you can use your traditional rules of thumb as a hunch. It looks like this fire was started over here, but it's no more than a hunch. It's not something that should get somebody convicted and sent to prison for 24 years, or to end their life for conviction for murder. But it can say, I'm going to start my investigation here because it looks like that's where the fire began. So the traditional indicators still have value, but they must be kept in their place and give way to the science that has taken over. Okay, that's it.
다시 한번 수고해 주신 카티스 교수님께 큰 박수 부탁드리겠습니다. 다음으로 중국의 난 발표자님을 모시고 홍콩 포트 화재에 대한 발표를 듣도록 하겠습니다. 큰 박수 부탁드리겠습니다.
Good afternoon, distinguished professors, experts, and colleagues. My name is Hunan, and I'm currently a lecturer at Anhui Xinhua University in China. My research focuses on building fire prevention and control. Today, my presentation is titled Analysis of the Hong Kong Unfocal Fire, Incident Development, Causes, and Fire Safety Implications. The presentation is organized into 4 parts. First, I will introduce the background of the incident. Then, I will briefly review the fire incident. After that, I will analyze the main causes of the fire. Finally, I will discuss the fire safety implications. Let me start with some background. Urban high-rise residential buildings are becoming increasingly common in densely populated cities around the world. While they provide efficient land use and accommodate large populations, they also present unique challenges for fire prevention, emergency response, and evacuation. Large-scale fires in such environments often involve complex fire dynamics, rapid vertical spread, and significant rescue difficulties. The residential estate where the fire occurred consists of 8 buildings with a total of 1,984 residential units. Each building has 31 floors, with 8 units on each floor. According to data from the 2021 Hong Kong population census, the total population of the estate was 4,643. Prior to the incident, the estate was undergoing external wall renovation, and all buildings were covered with scaffolding and protective mesh. With this background in mind, I will now move on to the fire incident itself. At approximately 14:51 on November 26, 2025, the fire broke out in one of the buildings. 10 minutes later, the fire spread to other buildings. At 15:02, the fire was upgraded to a 3-alarm fire. At 15:34, it was further upgraded to a 4-alarm fire. By 7 buildings had already been evacuated in flames. At 18:22, the incident was escalated to a 5-alarm fire. At 1:50 on November 27, open flames had been extinguished in 3 buildings, while only scattered fires remained in the others. However, at 23:15 that night, one building ignited with significant flames, and 2 other buildings showed visible fire activity. Finally, at 10:18 on November 28, the fire was largely extinguished. The entire incident lasted 43 hours. and 27 minutes. According to official and media reports, 168 people died, including one firefighter, and 79 people were injured. Many victims died indoors due to smoke inhalation and the rapid loss of the fire control. A total of 2,311 firefighters and emergency personnel participated in the rescue operation. 7 of the 8 residential towers were severely damaged by the fire, automatically classified as a fire-alarm fire by the Hong Kong Fire Services Department, the second highest fire alarm level in Hong Kong. This fire became the deadliest fire incident in Hong Kong since 1997, with the scale of casualties and destruction being extremely rare in the city's recent history. After reviewing the background of the fire incident, I will now move on to the analysis of the causes of the fire. The fire occurred in a residential complex while external process maintenance working was being carried out. Prior to the incident, a large number of bamboo scaffolds and dust protection lights had been installed around the building, and many windows were covered with foam protecting materials. According to preliminary investigation data, the fire initially started in the protective lighting on the lower external of one building. After 10 minutes, the fire rapidly spread through these external materials to nearby structures. The exact ignition source is still under official investigation, and the law enforcement agencies have already made arrests related to suspected violation of construction regulations. From the perspective of fire science, several key factors contributed to the rapid fire spread. First, combustible exterior covering materials. Materials used in the renovation work, such as bamboo scaffolding, dust-proof lights, waterproof tarpaulins, plastic protective mesh, and foam coverings, have relatively low ignition points. Once exposed to a fire source, they can ignite easily and promote rapid flame propagation. Second, the chimney effect. The scaffolding surrounded the entire building and created cavities between the scaffolding and the wall. In addition, the building facade and rest structure features together. These conditions likely produce a chimney effect, accelerating the upward spread of the fire. Third, a combustion chain reaction from the outside to inside. Burning exterior materials could ignite covered windows and indoor combustible materials, allowing the fire to spread from the outside facade into interior spaces. Fourth, fire jumping between buildings. Flames and burning debris may have crossed open spaces between buildings, causing the fire to jump between building facades and form a chain reaction spread. The fact that the fire spread from one building to 7 clearly demonstrates the importance of the separation design within building clusters. Reports indicate that at least one building's fire alarm system had been temporarily disabled. The reason was to allow construction workers to move in and out of the building more conveniently. As a result, the early warning function was limited during the initial stage of the fire. In addition, the rapid spread of smoke and the failure of resistance to hear alarm signals may have delayed indoor fire response measures and evacuation actions. Limited firefighting equipment also contributed to the delayed control of fire. The fourth limitation involved the aero-ladder trucks. The main operational firefighting ladder vehicle in Hong Kong has a maximum walking height of 56 meters. However, the building involved in this incident was 31 stories high, exceeding 90 meters, and had been standing for 42 years. This means that when the fire spread to the middle and upper floors, existing external rescue equipment could no longer reach the affected area effectively. The second limitation involved drones. 2 drones operated by the Hong Kong Fire Services Department were deployed at the scene. However, they were mainly used for lighting or on-site reconnaissance. The operational environment of high-rise fire is fundamentally different from the normal flight conditions. Once a large fire develops, intense thermal convection occurs, creating highly unstable turbulence and strong wind fleets around the fire site, often described as a chimney effect airflow environment. Under such conditions, most existing drones lack sufficient power and wind-resistant capability to maintain stable flight, let alone perform precise firefighting operations. In addition to environmental limitations, payload capacity represents another major physical constraint. Drones would not only need to carry the weight of fire hoses, but also withstand the significant recoil force generated by the fire pressure water jet. Currently, some drones on the market can extinguish fires by dropping fire extinguishing bombs. But in the case of a 5-alarm fire, the amount of extinguishing agent they can carry is extremely limited. To truly address the challenge of high-rise firefighting drones cannot rely on single unit operations. Instead, they would need to operate as coordinated drones, one with collective firefighting capability. This incident provides several important lessons for fire prevention and firefighting in high-rise or densely populated residential buildings. During facade maintenance or renovation, residential complexes must strictly enforce fire-resistant standards for construction materials. Combustible covering materials should be prohibited, and scaffolding and protective light should use high-grade, fire-resistant materials. High-rise and large residential buildings typically rely on automatic fire alarm systems, as they are primary early warning and evacuation guidance mechanism. These systems must remain fully operational during construction or renovation periods, and intentional shutdowns should be strictly prohibited. This fire showed a rapid spread from the exterior into multiple buildings, highlighting the need for stricter planning and inspection of vertical and horizontal fire separation measures within building complexes. This concludes fire-resistant zoning, facade insulation systems, and smoke control systems. Firefighting equipment and tactics need the following improvements: more robust high-res firefighting water supply systems, fire engines equipped with advanced high-pressure jet technology, deployment of high-power industrial firefighting drone fleets operating under unified command systems to conduct coordinated and separation-based firefighting operations. Finally, residential or high-rise buildings should be equipped with basic fire evacuation knowledge, including how to identify safe escape routes and how to block smoke infiltration during fires. Such knowledge is essential for reducing casualties during fire emergencies. My presentation concludes here. Thank you for your attention.
Yeah. Okay. Good afternoon. I'm Daniel Gore, Explosion Safety Consultant for FIGHT, and today our topic is about preventable by design and engineering, real case incident, and the cost of missing early risk assessment. So FIGHT Corporation is founded in 1945, HQ located at Blue Spring, Missouri, manufacturing plant in US, Canada, UK, Belgium, and regional office in 10 other countries, including mine in Kuala Lumpur, Malaysia. So we do overpressure, explosion protection, and fire protection business. And now we are more into explosion protection. So I will start with a bit of fundamental, then we go into some case studies, 2 brief case and 1 in-depth, and finally what we can do to prevent things from happening. So we start from fundamental, always fire elements, ignition, combustion, dust, or fuel and oxygen. So when we have the 4th element, we call the flash fire. When we have a dispersion dust in the air, we call it dust cloud. And when we have a fire triangle comes along, we will have a flash fire, something like this. Then the 5th element is confinement. You can call it as enclosure or dust collector. In these 5 elements together, we will have explosion. Right. So when we talk about explosion, often we talk about dust hazard. We also focus more on dust on this section, not gas. So when we talk about dust hazard, why dust? It's because dust often have a higher rate of combustion. Why? It's because dust is all because of the particle size. The smaller the particle size, we will have more surface area to burn, then will increase the rate of combustion. That's why you have a very fast combustion. So first step of managing the dust hazard is to understand your dust and material properties. So you can get it from vendors, probably from MSDA sheet or from textbook or NFPA standards or any online database. So when you need to do testing, when data is not available, the particle size or moisture content is different from the published data, or mixture is being handled. What is mixture being handled meaning that you have more than 2 products and the test data is only reflecting 1 product. So mixture is handled, for example, in grain industry, animal feed, or fly industry, you have vitamin added in, so that is called mixture. So on this table, I just got it from NFPA 652-2019. So as you can see, not all starch is same. There's different type of starch and have different values, as well as sugar as well. So even if the product is the same, but the particle size is different, you will have different value as well. That's why the first slide saying that moisture content and particle size is very crucial. So example of hazardous dust, we have agriculture dust, carbonaceous dust, chemical dust, and metal dust. So if this dust is somewhat familiar to you, you may want to take note. Okay. So what is dust testing? These are the common dust testing that are available in the market. We'll go deep into here. So the first dust testing is what we call go or no-go test. What it does is we just do explosion, we just ignite the dust and see if they're combustible. So if this fails, then all other is irrelevant. If it passes, then we need to go to another test, severity test. is how big is the explosion and how fast the explosion happens. I'll dig deep into that later. Other than that, it's more on the atmosphere or flammable atmosphere. We need to know the minimum concentration required for the dust explosion, and we need to know the limited oxygen level. And the third one is the sensitivity of the dust. Then is the emission energy, usually referred to spark, temperature for layer, dust layer, and temperature for dust cloud. Okay. So, as I mentioned just now, the severity of the dust explosion is determined by this explosive dust test, where we want to know the rate of rise of pressure actually developed on an explosion, on a contained explosion that we call as Tmax. These are two information that we want to know. Then we talk about the primary and secondary explosion. On the primary explosion, usually referring to where the explosion originates. For this case, or for this picture, shows that the explosion originates from this equipment, and the equipment fails. That's why the pressure and flame comes out. If the environment is dusty, the blast wave will disrupt the dust on the floor, on the equipment, or on the ceiling, and create a dust cloud. And the flame that comes later with all the initial source, it will create a flash fire or a secondary explosion, as you can see on the second picture on your right. So this is another vector animation just to show you what is secondary explosion. So let's say if the explosion originates from the siphon, you have a big shot on the building which causes destruction of the dust on the floor, on the ceiling, on the equipment, same as the previous slide. Then you have a lot of dust cloud, dispersion of dust, and the siphon fails. Just now I mentioned the siphon enclosure strength is smaller than the Tmax. It may fail and start to create explosion on the equipment as well. And as it fails, it creates ignition source on the dispersion of the dust and create a secondary explosion on the external in the building, as well as the dust collector, as flame will propagate to the dust collector. And if the explosion pressure is high enough, this building, instead of flash fire, will become a containment, therefore the building will fail as well. So, let's move on to a case study. We have 3 case studies, and we go through very quick on these 2, and the last one will be that. So on April Sugar is a very famous explosion incident that happens in US, where they make sugar dust. Everything began from the conveyor belt, and based on the investigation, it is due to overheated bearing, which caused 14 fatalities and 60 injuries. So from this picture, we can see before the incident, there's a lot of dust laying down in the equipment and as well as the process equipment. So this caused secondary explosion and caused what happened, as what you can see in the previous picture. The second case is West Farm Hospital. What they make is they make rubber for syringe rubber plunger or rubber stopper. What they make is those rubber small equipment or small parts. So in this process, actually it's a very clean environment where the rubber is rolled in this roller, and they have this ethylene dust coated on the rubber, and then the fan blow it, and over the time, the ethylene dust kept in this compounding area through the aircon latch. So a lot of dust is in this compounding area for over many years, and when there is an incident of a small explosion happens, again secondary explosion happens, and what you can see is resulting the catastrophic explosion in this picture. So 6 fatalities, 38 injuries. So DBM meaning, this is what we're going to talk in depth. So what they do is they make corn dust, and 5 fatalities and 14 injuries. Okay, so everything happened from a bit about the process. First, they have this temporary line to consolidate the pump, the blower, and the siphon as well from the left to the right. So what happened is that from the process, they have 2 mil go to the siphon and to the toric filter, and the bottom of the outlet siphon is flow to this cyclone, then shifter, and the dry quick filter. As you can see, they utilize the same blower instead of separate respective blower and respective cyclone, they consolidate it. So what happened here is because they consolidate it, the flow is insufficient that caused the product to lump in the connecting pipe. So based on the investigation, they believe that there's smoldering inside the pipe between the connecting pipes and caused the small explosion here and flow to the rotom on this mill and caused the first explosion, primary explosion, as well as flow to the receiving hopper and later to the dust collector called dry grid filter and another explosion here and flow back to the D mill and the B mill. Okay, and this shows more details what contained inside the D mill. There's a lot of cyclones and later to the grid dry. So what is the flaws? There's a lot of flaws on this explosion. I just picked a few which is most critical due to time constraint. First flaws is DDN did not recognize the product they make is combustible. Even the SDS you can see here is not available during the investigation. Another flaw is that there's a lot of connectivity, interconnectivity pipes through this dry quick filter to the mu B and mu D. So there's 40 plus equipment directly and indirectly connecting to these dry quick filters, and there's no isolation, so flame will propagate through the other equipments. So as you can see here, this is a typical frame front video where the pressure, where the explosion, where the flame propagates, the explosion pressure will disrupt the dust inside the pipe and the flame follows later. So as mentioned as the illustration just now, the flame originates from the cyclone, goes all the way to these dry quick filters, and the dry quick filters due to all the connecting pipes, it flow back to mu B and mu D, and this is what you see here, the animation from CSB investigation. So a big explosion that caused the whole factory burn down. So the another flaw that we understand is that the fugitive dust management. There is a lot of dust again on the floor, same goes to infrastructure. As you can see, the picture A actually shows what happens, the condition 3 months before the incident. Picture B is 2 weeks before the incident, and picture C is day before the incident. So this shows that there is no housekeeping. The dust is just laying on the floors. So what is the windfall? The windfall of this is three officials sent to prison due to falsified documents or fraud, and Gideon sentenced to pay 10 million in restitution and 1 million fines. So how can we prevent it? We can prevent it. First, I explained about the standards. We have 2 standards that our guidelines we can follow. The American Union, we have ATEX standards that we can follow, and in US, this is called guideline and PS652 that we can refer as well. This is 2 globally recognized standards and guidelines. There's also some local guidelines, standards. Singapore, there are 667. In China, they have GPT 24353. So there are some local guidelines as well. So next is about the consultation guided journey. These all can be prevented if we have this executed. So on this consultation guide journey, first we need to understand the material properties, whether it is combustible or not combustible, and the characteristics of your products. Then we go on to analyze the hazard of your process, explosion hazard on your process, and then we develop a mitigation strategy or develop strategy to So inspection, test, and maintenance include not only the explosion protection device, also includes all the motors, pump, blowers, bearings, etc., all the process equipment. So again, task testing, the first one is same slide as just now. And then steps of ATEX risk assessment. I just take ATEX as an example. First, you need to know your overall process and material, do testing if required. And then we need to address the risk assessment. Then we need to do a risk assessment to determine the likelihood of flammable atmosphere, initial risk assessment, and the severity of the primary and the secondary explosion. After we define this, and the flammable atmosphere is part of the HAC study as well, what we call the hazardous area classification, what we call the zones 20, 21, or 22 for gas in zone 0 and 1, 2. After we do the risk assessment, we define the basis of safety. How do we prevent again the flammable atmosphere? How do we prevent the ignition source? And if we cannot do both, then we need to have a mitigation method. Then after we did everything of this, then we need to have a countermeasure, or not countermeasure, what we call that, implementation. Then we have everything documents, and it is called the explosion protection documents. It's all in one document. So what we did in the past, I just completed one of those with about 160 pages on the flour business. So what is mitigation method? Mitigation method is the protection of the equipment. So there is, in the industry, there is a few common use protection method. One is venting, what we call pre-venting. The first picture here is pre-venting, but you often have comes with the explosion pressure. You often come with a flame path here. So make sure that you have a safe flame path for pre-venting. You also can use vent ducting, right? But vent ducting often not applicable for equipment that is far from side windows or side walls. Then we have flameless venting, where you can use it indoor, but this is not good for any toxic dust, because the gas or the dust, carbon dust, will come out. The third one is the suppression method, where we similar easy understanding or layman terms is you have a fire extinguisher directly installed into the equipment to activate and pump out a suppression agent to kill off the fire. Then, as mentioned just now, we also need to have isolation. And the passive isolation, this is commonly known as a flapper valve, but the cons on this is the explosion pressure and the process pressure need to be at opposite direction. And then we also have the chemical suppression, similar to suppression, but this is on the pipe, as well as the mechanical, like gate valve or pinch off on the pipe. So there is many protection method, different kind of protection method. There's pros and cons on each protection methods. So the correct approach is to use the appropriate method based on the site condition or based on customer process, whichever fit the best. Or the protection method is customized or is made based on one-to-one solution. It's not copy customized solution. You need to make sure the placement of the protection equipment is correctly placed. For example, a dust collector, you do not want the filter to block or disrupt the flame path for venting. You need to have the correct setting, make sure that the process condition does not open or activate the system. Appropriate installation and further maintenance is more towards the supplier manual, so you need to make sure it's installed correctly, otherwise it will not work as what it is, and as well as maintain it, otherwise it may not work as what it is. Management of change, when you have any changes in your process, you may need to redo the design. For example, if you change your product, your KST value and Qmax value may differ, and you may need to redo the design process and make sure that the system works as it is. So recommendations, if you do not have DHA conducted, please get it done. Then if you have DHA completed, make sure you have an action plan based to take note on all the recommendations in the DHA report. And then if you have any new process or equipment, make sure you get your DHA completed on the proposed design as well. This is more on the management of change. And then employee trainings. Then you need to review the SOP as well, make sure the accuracy and ensure the employees train on the SOP. For example, no smoking in the site or something like that. Preventive maintenance on the process, not just the explosion protection device, it's also the pumps, motors, bearings, etc. So failure of pumps and motors is not just production downtime. It may also create an ignition source to an explosion as well. So this is very crucial. Check on your explosion protection system, make sure that they install and inspect according to the standard. If you have local standard, please follow the local authority having jurisdiction. So NFPA 68 and 69 could provide a good guidance what to expect. And then most important is to maintain the documents on your explosion protection system. For example, if you have any calculations or any calculation, it is very important to put it in documents. If you have, for example, for pipe, you have bank calculations documents, as well as if it is at the system, we often come with drawings to show where is the equipment drawings and all the input information shown on the drawings. So I think that is it for me. Thank you.
박수 부탁드리겠습니다. 네, 다음은 아까 하기로 했지만 못했었던 키르기스탄의 가라타이 행정관께서 발표를 하시겠습니다. 큰 박수로 맞이해주시면 감사하겠습니다.
안녕하세요. My name is Sarata Janjuli, I'm from the Kyrgyz Republic. Now it would be difficult to present after you guys both the presentations. My presentation is about fire investigations in the Kyrgyz Republic, and I will try to explain about the fire investigation process and statistics in the Kyrgyz Republic. Let's start. Fire represents a critical emergency situation in the Kyrgyz Republic, posing a significant challenge for both authorities and residents. Each year, the country experiences between 3,000 and 5,000 fires, highlighting the frequency and severity of this issue. This fire results in substantial economic damage affecting business, infrastructure, and the overall economy, while also posing grave risks and to the population, safety, and well-being. The residential sector is particularly vulnerable with a high incidence of fire occurring in homes and apartments, often due to outdated electric systems, inadequate fire prevention measures, and limited public awareness about fire safety. Efforts to address this challenge include enhancing firefighting capabilities, increasing public education on fire prevention, and implementing stricter safety regulation to reduce the risk and impact of fires. Let's go to fire statistics. Number of fires in 2025 was 3,000 to 3.5. Number of deaths from 40 to 60, and estimate about $10 million. If you can show $10 million, it's about 3 or 4 schools, for example. Seasonality of fires. Peak period is autumn and winter. It's heating season. Key reasons for seasonal increase is intensive use of heating stoves or in private houses, overload and aging of electric networks, increased use of electrical heaters and unsafe devices. You can see improper installation and maintenance of heating system. Additional risks is lack of regular inspection, electric wire, low awareness of fire safety rules, use of low quality or outdated equipment. Primary and causes. Here is the general causes and primaries of fires. Up to 60% it's a human factor. First one is electrical wiring, short circuits, and improper use of stoves, careless handling of fire, and smoking. Here you can see where fires most often occur. First one is, of course, private houses, after apartments, outbuildings, farm buildings, warehouses. Here is two types of investigation. First type is traditional methods, second type is modern technologies. Traditional method, it's site inspection, there is analysis, witness interviews. As a result, is limitations, slow process, human error, limited detection of hidden causes. Second type is using modern technologies. It's 3D scanning for all the fire scheme, drones for aerial photography and image assessment, thermal imaging and infrared cameras. Advantages: prices, documentation of the scheme, visualization of fire origins and spread. Laboratory and analytical technologies, also important part. Use of chemical analysis to identify occurrence and flammable substances, gas chromatographs and spectrometers for analyzing fuel residues and combustible materials. Computer modeling of fire spread. Application of artificial intelligence system to predict fire behavior and determine the primary point of origin. Digital technologies and artificial intelligence. Surveillance systems and IoT devices, real-time monitoring of fire incidents, AI and machine learning, automatic detection of anomalies and suspicious factors, fire databases storing information for causes analysis and prevention of recurrence, VR and AR technologies training experts and simulating fire scenarios for investigation practice. As a conclusion, we got in Kyrgyz Republic, we implement of modern methods in the Kyrgyz Republic allows reducing investigation time, increasing accuracy in determining causes, and minimizing human error. Conclusion is combining traditional and modern technologies ensures effective fire investigation and prevention. Okay. Thank you. 감사합니다.
수고해주신 카라테님께 다시 한번 큰 박수 부탁드리겠습니다. 마지막 순서입니다. 김일범 과제자님께서 홍콩 왕폭 코트 화재 조사 결과를 주제로 화재 위험성과 예방 대책에 대하여 발표를 해주시겠습니다. 큰 박수로 맞이해 주시면 감사하겠습니다.
네, 반갑습니다. Hello, I would like to express my deep gratitude to Professor J. Patterson of the United States and research program of China and administration Karatai of Kyrgyzstan and Daniel Ho of Malaysia for attending today. Today I present to one focus fire investigation in Hong Kong. Please left to the conference room. I will give a presentation in Korean. Are you okay? 지금부터 저는 한국어로 가겠습니다. 제가 발표할 내용은 홍콩 왕폭부터 화재 조사 내용입니다. 제가 홍콩 왕폭부터에 직접 다녀왔는데 그 조사 결과에 대해서 박승호 부장님께서 꼭 국제 세미나에 좀 발표를 해줬으면 좋겠다. 그래서 제가 오늘 주제는 없지만 이 자리에 서게 됐습니다. 제가 직접 현장을 가고 조사하고 느낀 부분에 대해서 말씀드리겠습니다. 먼저 흔한 연구께서 자세하게 이제 화재 조사, 또 인명 피해 발생 사유, 연소 확대된 사유, 또 예방 시스템, 화재 진압 대응까지 이렇게 자세히 말씀해 주셨는데, 저는 이제 화재 조사 결과에 대해서, 그 다음에 화재 조사 포인트, 위협 포인트 위주로 이렇게 말씀드리겠습니다. 목차는 홍콩 왕폭포트 화재 조사 결과, 두 번째, 홍콩과 비슷한 마카오의 건물 차재 안전 시스템이 어떤지 살펴보고요. 그리고 한국의 실태를 살펴보고, 제가 화재 예방 대책에 대해서 말씀드리도록 하겠습니다. 먼저 홍콩 왕폭포트 화재 조사 결과입니다. 이게 제가 직접 홍콩에 가는 거예요. 여기 이제 한국인들 많이 가는 인명굴대 그쪽에 취재를 간 내용입니다. 먼저 화재는 25년 11월 25일 발생했습니다. 홍콩 북부의 타이포 구역은 이제 중국 신전하고 붙어 있는 지역, 한국의 최고 북쪽에 있는데 31.8개도 아파트가 단지에서 불이 났는데 8개 동 중에서 9개 불이 났습니다. 그래서 소방대가 5분 내에 도착했음에도 불구하고 초기 진화에 실패하고 대응 5단계까지 상황입니다. 그래서 대응 5단계는 150명 이상 소방관이 출동하는 최고의 단계입니다. 홍콩은 5단계였습니다. 우리는 3단계입니다. 홍콩은 5단계입니다. 최고 단위의 대응을 했음에도 불구하고 건물의 8개 동 중에 9개는 전체적으로 피해를 입었습니다. 화재는 F동 저층에서 먼저 시작되었는데, 그래서
가연성 비계를 갖고 10분 만에 31.63까지 올라왔습니다. 화분 끄져버립니다. 잠깐 동영상을 보도록 하겠습니다. 이거는 홍콩하고 화재의 대응 단계별 알람 3단계로 화재가 발생하자마자 3단계로 확대했습니다. 화재가 확산된 것은 대나무 기계가 추락하면서 화재로 급격하게 이제 확산이 되는 중입니다. 지금 인터넷 때문에 안 되는 것 같아요. 잠시만, 인터넷에 문제가 좀 있는 것 같네요.
네, 트래픽이 있습니다.
네?
트래픽이 좀 있습니다, 지금.
트래픽 때문에 그렇죠.
예.
잠시만 기다려요. 지금 경찰에서 주민들 대피령을 내렸습니다. 그리고 오후 5시에 일단 최초 보고로 4명이 사망하고 3명이 다친 걸로 최초 보고요. 지금 건물 건너편에서 시민들이 보고 있는데요. 화재는 대응 5단계로 확산합니다. 화재가 대나무 기계하고 관련해서 천막에서 요소하더라고요. 오후 7시는 이제 거의 최승계에서 불티가 비산되면서 전 건물로 유수합습니다. 그래서 화재는 블록 8개로 32일 8개 정도 확산해서 거의 불가하게 확산되었죠. 8시 30분이고요. 최초 보고되는 것은 13명이 사망하고 28명이 부상하는 그런 사고를 당했습니다. 화재는 이제 건물 전체로 확대되고 있습니다. 오간에 밤 10시 30분, 시진핑 주석이 사고에 대해서 기술과 제주자, 행안부 장관, 전미 시장 화재는 지금 4단계로 떨어졌고요. 하지만 화재는 여전히 그 다음날 3개 동에 계속 연속 확대되고 있습니다. 지금 7개 동에 계속 연기가 나고 그 다음날 오후 3시입니다. 그 다음날 오후 3시에 55명이 사망하고 275명이 여전히 실종이 그런 상황입니다. 그 중에 16명은 크리티컬한 굉장히 심각한 그런 상황입니다. 발렌티어 자원봉사자들이 의료라든지 블랑켓, 음식 등 지원하고 있습니다. 8시 24분 그 다음에 사망자가 굉장히 늘어나고 65명으로 늘어나고 그 다음날 11시에 파이어는 다시 재발화되었습니다. 왕타이 동에서 재발화되었고 그 다음날 열렸습니다. 83명으로 사망자는 늘어나고 있습니다. 소방본부에서 화재가 이제 완전 진압했다고 발표를 했습니다. 완진을 선언했습니다. 28일 날 화재 재발을 위해서, 재발 방지를 위해서 물을 뿌리고 있거든요. 화재는 거의 완전히 진화되었다고 선언을 했습니다. 아직 정확한 사망자 숫자는 알려지지 않는데 화재 발화 지점에 대한 화재 조사는 계속 이루어지고 있습니다. 네, 컴퓨터가 다운돼서 다시 시작했습니다. 그 화재는 지금까지 사망자는 161명으로 보고되고 있습니다. 그 동별로 사망자를 이제 분석을 해보았습니다. 그래서 최초 발화 지점이 F동인데 풍향에 의해서 서쪽으로, 동쪽에서 서쪽으로 연소가 확대됐습니다. 그래서 조사 결과로는 전체 사망자 90%가 E동과 F동에 직접되었다. 통계를 통해서 알 수가 있습니다. 세부인에서 82명 사망자가 발생했습니다. 그래서 사망자는 그림에 보다시피 E동, F동에 많이 집중되어 있습니다. 그래서 풍향에 의해서 건물들이 열기에 직접적인 피해가 발생할 때 이를 빠른 대피가 필요할 것으로 분석됩니다. 화재 확산 주범은 대나무 비계에 있습니다. 홍콩의 이제 특징이 뭐냐면 굉장히 고밀도되어 있고 좁잖아요. 그래서 우리가 왜 대나무 비계를 쓰느냐, 저도 이제 현지 가서 알았는데 지금은 이제 홍콩도 굉장히 5, 60년대 고도화 발달되다 보니까 굉장히 좁습니다. 그래서 고층 빌딩이도 차가 못 들어가는 게 많아요. 네, 그럴 때는 대나무 비계를 설치할 것을 쇠 파이프로 할 수는 없고 사람이 메고 갈 수 있는 대나무 비계를 이제 선호합니다. 그리고 두 번째는 대나무 비계 협회에서도 있고 대나무 비계 설치를 하려면 대나무 비계 설치 기사 자격증이 있어요. 그래서 이러한 협회와 또 기자격자에 대한 이런 압력 단체가 되어가지고 이 시장이 그 홍콩에서는 가장 저렴하면서도 빨리 쉽게 할 수 있는 그런 문화와 시스템으로 정착되었다. 이렇게 관계자한테 그런 이야기를 들었습니다. 그리고 저희가 홍콩에 이제 직접 구룡이나 이제 홍콩섬에 이제 가서 직접 봤는데 실제 소방차가 못 들어가는 데가 많습니다. 그런데도 거의 지금 현재도 대나무 비계 공사를 많이 하고 있어요. 하고 있는데 그런 거는 사람이 메고 직접 운반을 해서 사람이 전달해가지고 고층으로 대나무 비계 공사를 하는 것 같습니다. 그는 문화적인 특징이 있다는 것을 이해해 주시고요. 대나무 비계는 이제 거대한 땔감이 되어서 초기에는 잘 발화되지 않다가 불이 붙으면 지금같이 순식간에 무너져요. 순식간에 이게 30층까지 매달려 있던 게 무너지면은 거대한 이제 하얀 덩어리가 됩니다. 그러다면서 다시 수직으로 재발하는 그런 현상이 있습니다. 그 다음에 나일론 소재의 방진망인데요. 여기에는 이제 홍콩에는 방진망에 대한 난연이나 뭐 준불련이라든지 이런 규정이 없습니다. 그런 가연성 나일론망을 사용된 거죠. 그래서 이게 담뱃불이나 조그만 불씨라도 붙으면은 수직으로 뾰족하게 인수합대되는 그런 위험이 있습니다. 그래서 조사 결과 방진망 인수 시 발생한 고농도의 유독가스가 실내로 유입돼서 거주자의 사망자의 직접적인 원인이 된 거고요. 다음은 구조적인 원인으로 건물 간 굴뚝 효과를 볼 수 있습니다. 건물 간의 사이가 워낙 좁기 때문에 바닥에서 발화되면 굴뚝 효과로 해서 상승 규류에서 하염이 위로 급격히 상승된다. 그래서 이 하염이 온도가 상승하면서 인접동의 유리창을 파손시키면서 실내 거주자가 거주하고 있는 실내로 하염이 유입되어 있습니다. 그리고 여기서 제가 내용을 적진 않았는데 공사 중에 유리창의 파손을 위해서 스티로폼을 다 붙여놨어요. 그래서 실제 거주자는 안에서 밖에서 어떤 상황이 벌어진지 알지 못했대요. 하염이 들어오기 전까지 불이 나고 갑자기 스티로폼이 녹으면서 유리창이 깨지면서 하염이 프레셔오버처럼 실려 들어오고 그래서 대부분 다 그런 이제 거주자들이 그런 위험을 당했고 거주자 대부분이 70~80%가 65세 노인층이었고요. 여기가 고층 아파트인데도 8평짜리 아파트입니다. 국민주택 30년 살면 임대 전환해주고 분양해주고 이런 저소득층의 거주지라고 보시면 됩니다. 다음에 기계적인 실패입니다. 스프링클러의 작동이 불능입니다. 열기에서 스프링클러 헤드는 이제 개방이 되었습니다. 유리관이 벌브가 68도나 70도 되면 깨졌는데 배관 속에 물은 녹지 않았다. 메인 밸브에서 뭔가 잠겨져 있다는 거죠. 그래서 확인을 해본 바 실제 소방 설비가 작동하지 않았다는 것을 소방당국에서 발표했습니다. 스프링클러 관리 상태를 점검을 했는데 소방펌프 제어관 전원이 차단되어 있었습니다. 그래서 인위적으로 이것을 작동을 멈춘 걸로. 그리고 주민들이 비상벨을 대피하면서 눌렀는데 경보음이 들리지 않았다. 그래서 경비실에서 수신기 전원까지 꺼놨다고 그런 스프링클러 경보기까지 차단시키는 그런 문제가 있었고요. 소방 밸브 역시 OS&Y 밸브를 완전히 잠가는 것을 조사 결과 확인이 됐습니다. 그 다음에 거주자는 이제 40%가 아까 제가 잘못 말씀드렸는데 40%가 65세의 고령자입니다. 여기가 이제 임대 전환주택 8평짜리 아파트인데 30년 이후에 임대로 전환해주는 그래서 대부분 다 자가주택으로 받기 위해서 30년 동안 오래 거주하는 노인들이 대부분이라고 볼 수 있습니다. 그러한 저소득자들이 사는 공동주택이기 때문에 아파트 관리가 제대로 안 된다. 여기에 사회적인 요인으로 관리 부실과 방치된 위험이 있습니다. 안전 보수를 위한 장기 수선 충당금 집행 지연이 대형 인명피해로 이어졌다고 이렇게 보입니다. 다음 홍콩에 대해서 봤고요. 인근에 마카오를 가서 제가 어떤지 살펴봤습니다. 마카오에도 같이 이런 한 건물 자재 시스템을 쓰는데 마카오는 보호망에 대한 법령 규정이 있습니다. 그래서 보호망 테스트에서 4초 이내에 자가소화되는 자기소화성 테스트를 거치지 않으면 현장 반입이 안 됩니다. 그래서 마카오 소방국에서는 현장 샘플을 직접 변소 테스트해서 불합격 없이 공사를 하지 않도록 이렇게 엄격히 제재를 하고 있습니다. 그래서 중국의 같은 나라에도 홍콩 성과 우리나라 따르는 성으로 일반이 홍콩과 마카오의 제도적인 기반이 좀 다르다. 그래서 마카오는 굉장히 규제가 강력하게 되어 있다는 것을 확인할 수 있었습니다. 그래서 마카오에는 이러한 이제 사고 예방을 위해서 소방밸브 정지 시 사전 신고와 24시간 안전요원 배치를 법적으로 의무화해서 인위적인 설치를 무력화를 하고 있습니다. 이러한 인위적으로 하는 것을 원천적으로 차단하고 있습니다. 우리나라 같은 경우도 예를 들어 천안 주차장 화재나 인천, 청라 아파트 화재도 그다음에 또 있죠. 대전의 현대 아울렛 이 공통점이 뭐냐? 소방시설을 임의적으로 차단해서 스프링클러가 작동하지 않아서 대형 인명피해가 발생한 사례입니다. 그래서 우리도 이러한 제도적인 원천적으로 소방시설을 임의적으로 차단하지 못하게 한 그러한 강력한 법적인 조치가 필요하지 않을까 이랬습니다. 그래서 법적 강제성을 통해서 관리 주체의 안전 책임의 의식을 고취시키고 설비 임의 차단을 중대 범죄로 규정하는 것이 중요하다고 볼 수 있습니다. 우리나라의 실태에 대해서 살펴보겠습니다. 우리나라의 초고층 건물은 대부분 다 수도권과 부산에만 집결되어 있고 통계로는 60%가 수도권 쪽에만 몰려 있습니다. 최근 5년간 국내 통계를 보면 고층 건물에서 누적 220건으로 지속적으로 약 한 25건에서 최대 60건까지 지금 급격히 확대되고 있습니다. 그래서 저희도 건물 공사적인 건물의 방충망이라든지 아니면 가연성 패널을 사용하는 것을 앞으로 이런 사고를 예방해서 미리 준비해야 되지 않을까 이런 생각을 하고 있습니다. 재산 피해 역시 굉장히 폭발적으로 지금 증가하고 있는데 저희가 고층 건물의 재산 피해액이 작년 대비 3배나 증가하고 있습니다. 앞으로 대형 화재가 지금 예상되고 있는 그런 시점이라고 볼 수 있습니다. 저희는 이제 대형각 화재 참사를 통해서 가연성 외장재가 얼마나 위험한 줄 알고 우신골드 스위트 때도 저희가 한 20분 만에 38층까지 올라가는 것을 언론을 통해서 생생하게 이제 보게 되었습니다. 그래서 우리가 이거 건축 외장재 훈련하고 많은 노력을 했고, 우리 내화건축자재하고 협회랑 같이 해서 외장재 훈련하에 굉장히 노력을 했는데, 이거도 1만 평방미터 이상으로 제한이 돼서 유효무효한 이제 그런 법률이 되고 있는데, 좀 더 우리도 강력한 법률 개선이 되어야 되지 않을까 생각합니다. 예방 대책에 대해서 제가 간단히 말씀을 드리는데, 앞으로 우리가 이러한 AI 기술이나 화재 전조 경보 시스템 이런 4차 산업 기술을 활용해서 소방시설도 좀 획기적으로 바뀌어야 되지 않을까 이런 생각을 합니다. 그래서 시간별 스캔, 공간별 스캔, 설비별 스캔을 해서 데이터 관제를 통해 화재 발생 전 단계에서 90% 이상 징후를 감지를 하고 위험 요인이 있을 때는 로봇이 이렇게 미리 차단을 시킨다든지 이런 시스템을 도입하면 어떨까 이런 생각을 해봤습니다. 그리고 성능 유지 PBD 성능을 30층 이상 아파트 요양원까지 확대하자는 게 제 아이디어고요. 그리고 화재 시뮬레이션을 통해서 설계를 통해서 대형 화재 피해를 막는 그러한 설계가 필요하다고 생각합니다. 그리고 마지막으로 제가 제안하는 것은 초고층 전문 소방대가 필요하지 않을까 생각합니다. 우리가 수평적인 화재 진압보다 초고층 전문 소방대를 따로 만들어서 고청 화재에 특화된 그런 소방대를 만들어 보면 대형 화재 진압, 고청 화재 진압에 영향이 있지 않을까, 성과가 있지 않을까 그런 제안을 봅니다. 이상 이제 발표를 마치겠습니다. 네. 감사합니다.
다시 한번 큰 박수 부탁드리겠습니다. 이것으로 발표는 모두 마치도록 하겠습니다. 잠시 휴식 시간을 갖도록 하겠습니다. 행사장 밖에 커피와 다가가 준비되어 있으니 편하게 담소 나누시고 다시 오시면 되겠습니다. 그리고 CFEI 이수증 명단 작성 안 하신 분들은 나가셔서 작성을 해주시고, 그리고 판매점 같은 경우에는 요거 행사 패널 토론 시간까지 끝나고 그때 알려드리도록 하겠습니다. 잠시 후에 뵙겠습니다.